This is a perfect crystalline structure. We need structures with imperfections in order to create the climbing process. The first imperfections occur when one atom leaves the structure. If there is no atom, the bonds also disappear. This imperfection is named a point defect or vacancy, and it is defined as a space which is not occupied with an atom, which a vacancy is not enough to create a climbing process. It is necessary to increase the defect. For this, we need to quit a whole line of atoms, and this is what we call a dislocation. It is named like this because usually the lines are perfect, but suddenly a line stops in one point. So at this point the plane is dislocated because it is not continuous. It doesn't exist. It is important to say that the plane can move because the dislocation exists, but if the dislocation doesn't exist, it could occur a fracture because the material will be deformed. Now we need to create a process that displays the tablets. So we need a force that to create a movement and make the atom displaced. If the material has a dislocation, the force will let the planes be closer, and finally there will be a creation of a new bonds because the material tends to stay in the minimum energy space, which is the equilibrium. All of this take the conclusion that the material with the defects on his structure is tougher. Now, what happens is a big atom enters in a vacancy of the structure. This process is called doping structure. Now, if we try to make a force, the effect of this doping atom is a resistance to the movement. So, it will be more difficult to move the planes. This difficulty is called hardness. When the material is doped or when we exchange atom, the hardness is modified. This hardness will increase because the exchange of atoms creates a resistance, and it will be more difficult to make the climbing. Furthermore, we can see that the big atoms make the shorter bonds, so the structure will be far from the equilibrium.